In this lesson, we are going to look at what happens when you are solving an inequality and you have to multiply or divide by a negative number. And we can use a number line to investigate the effects of multiplying and dividing each side of an inequality by the same number. So let's say we have -1 is less than 2. And we can see on this number line that that is a true situation because -1 is smaller or further to the left than 2 is. Now let's see what happens if we multiply each side by 3. So we have -1 is less than 2. We multiply each side by 3, so we get -3 is less than 6. That is still true. Here's -3, here's 6. -3 is further left than 6. So if you multiply by the same positive number, your inequality will still hold true. If we divide each side by 3, so we have -1 is less than 2. We divide each side by 3, so we are left with -1/3 smaller than 2/3. That is still a true statement. -1/3 is to the left of 2/3 on a number line. So multiplying or dividing each side by the same positive number follows the same rules as when you are solving an equality or an equation. But let's look at what happens when we multiply or divide by a negative number. So we have -1 is less than 2. If we multiply each side by -3, I get a +3 and a -6. Well, the original equation was a less than. And so if I would have left it as a less than, I would have been saying -3 is less than -6. We know that's not true. So what we see here is that we must reverse the inequality sign for it to remain true. So now we're multiplying by a negative, and when we multiply by a negative, we have to flip the inequality sign. So let's see if that's the same thing with division. We have -1 is less than 2. I'm going to divide each part by -3. -1 divided by -3 is +1/3. 2 divided by -3 is -2/3. In order for that to remain a true statement, we need to flip the inequality sign. So this is a very important rule, and it's a very important difference between solving equations and solving inequalities. And what that rule is, when each side of an inequality is multiplied or divided by the same positive number, the inequality is still true. But when each side of an inequality is multiplied or divided by the same negative number, the inequality sign must be reversed. Now this is only for multiplication and division. If you subtract a number from both sides, that's okay. The inequality stays the same. But if you multiply or divide by a negative number, you must reverse the inequality sign. So let's think about whether or not we would be reversing the inequality sign. We'll solve it, and then we'll graph it. So -5s is less than or equal to 25. We want to get s by itself, so we need to divide by -5. And when we're dividing by a negative, we have to flip the inequality. So what we are going to end up with is we're going to end up with s. Now we have to change the inequality sign, so it's going to become a greater than or equal to -5. And so if we are going to graph that, we are going to be at -5. It's an equal to, so we shade it. And we are saying that the variable part is larger than -5, and larger means go to the right. If we look at B, 7a is less than -21. Now we are going to have to divide, and there is a negative in the inequality, but the question is, are we dividing by a negative? The variable has the +7, so we are just dividing by +7. When you divide by a positive, nothing changes. This stays a less than, and in this case it will be -3. So we circle our -3, we leave it open because there's no equal sign. We're saying that the variable, the a part, has got to be smaller than -3, so that means go to the left. So if we divide by a negative, you have to flip the inequality. But if we divide by a positive, the inequality stays. Y divided by -4 greater than -3? When we are dividing by a value, the inverse operation would be to multiply. So we need to multiply both sides by -4. And when we multiply by a negative, we're going to have to change the inequality. -4 divided by -4 is just 1, so we're left with y. We need to switch the inequality because we were multiplying by a negative. And -3 times -4 is +12. So we can't even use this number line that's shown, so I'm going to get rid of it. Have 12, put a couple to the right, a couple to the left, put a circle at 12, leave it open because there is no equal sign, and we are saying that y is smaller than 12. So we shade to the left. So we multiplied by a negative, we had to flip the inequality. In this one here, we are going to do the inverse of dividing by 3, which is multiplying by 3. The 3 divided by 3 is 1, so we have k. Now because we multiplied by a positive number, the inequality stays. -2 times 3 is -6. So what we need to do is we need to draw a graph, put -6 in the middle, and when we circle -6, we actually shade it because of the equal sign, and we're saying that the variable is larger, so we need to move to the right. So now we want to solve this inequality. So this is a little more complicated, variables on both sides. Now it doesn't matter which way you move the variables. We can move them to either side. Most people tend to move to the left. So the inverse of adding is subtracting. So I'm going to subtract 1.8 from both sides. And so we will end up with -4.4a plus 14.6 greater than -5.2. That becomes 0. Ultimate goal is to get a by itself. So the inverse of adding 14.6 is subtracting 14.6. So we'll have -4.4a. That becomes 0. -5.2 minus 14.6 is -19.8. We need to divide by -4.4. Now we are dividing by a negative. That becomes 1. So we need to flip or reverse the inequality. So this becomes a less than, and then -19.8 divided by -4.4 is 4.5. So a is less than 4.5. So the same process as solving an equation, but the key to remember is when you are dividing by a negative, you need to reverse the inequality sign. And one last one. A super slide charges $1.25 to rent a mat and 75 cents per ride. Haru has $10.25. How many rides can Haru go on? So we need to choose a variable, write an inequality, and solve this problem. And then we want to graph the solution. So let's choose a variable. Let's let x be the number of rides. So we know it's $1.25 to rent the mat and then 75 cents per ride. So 75 cents or 0.75 of a dollar. We want to keep everything in the same units. And we know that Haru has $10.25. So he can't spend more than that. He can spend exactly that. So we need to see how many rides will cost him less than or equal to what he has. So our first step is isolating the variable. So we are going to subtract $1.25 from both sides. That becomes 0, so we have 0.75x less than or equal to 1025 minus $1.25 is $9. We need to divide by 0.75. We're dividing by a positive, so we do not have to worry about changing the inequality. 9 divided by 0.75 gives us 12. So what we're saying, if this is a situation, x represented the number of rides he could go on, we're saying x has to be less than or equal to 12. So that means he can go on less than 12 rides, or he can go on 12 rides because of the equals. Now when we're graphing this, because it's a situation, we have to think about limits. Can he go on less than 0 rides? The answer is no. You can't go on -1 rides. Could he choose to go on 0 rides? Sure. And then he can go all the way up to 12. So we make our number line between 0 and 12. And now we have to think about this still. Okay, 12 is included, so I'm going to include 12. It's shaded. Each of these represents the number of rides. We can't go on half of a ride or a quarter of a ride. So we actually just put dots at each of the values. You don't shade in between because we can't go on part of a ride. So that's how you would graph this solution. It's called discrete data. There's nothing between those points that satisfies this situation. So just to summarize, what we learned here is that solving an inequality, you use the same steps as in solving an equation, but if you end up multiplying or dividing by a negative value, you need to reverse the inequality sign.